Hello dear learners, welcome back to my channel. So today in this video we'll be discussing one short derivation, and the topic of the derivation is torque acting on a dipole when it is placed inside a uniform electric field. So before we start this video, I have a small request. If you are finding my videos helpful, then please do like, share and subscribe with your friends, especially to the ones who are preparing for their board exams. So with this, I would like to start today's topic. So we are discussing torque acting on a dipole in a uniform electric field. So here in this diagram, you can see we have uniform electric field E vector. Now uniform electric field is represented by parallel lines going in the same direction. So you can see these parallel lines going in the same direction, that is from left towards right, represents your uniform electric field. So sometimes the question comes to simply draw uniform electric field, you just have to draw parallel lines going in the same direction. So that will represent your uniform electric field. Now inside this uniform field we have kept an electric dipole. So you can see this is an electric dipole AB having charges minus q at A and plus q at B, and dipole length twice A. So this dipole is placed inside or within the uniform electric field, and you also can see that this dipole is inclined at an angle of theta with the direction of the electric field. So when this dipole is placed inside this electric field, it will experience a torque, and we are going to find out the expression for the torque acting on this dipole. Now we know that electric field lines, it originates from positive charge and it ends in the negative charge. So we can say that for this electric field, this side we have the positive field and this side we have negative. So we can consider this side is positive and this side is negative. So the field lines is going from positive towards the negative. Now in this dipole we have two charges, minus q at A and plus q at B. So as these charges are placed within the electric field, it will experience some force. And for finding that force, we will use this expression, which is for electric field intensity, which is nothing but the force experienced by the unit positive test charge placed within the electric field. So if you cross multiply from here, you will get F is equals to Q naught times E. So we will be using this expression to find out the force acting on minus q charge at A and plus q charge at B when it is kept inside this uniform electric field. The force on the minus q charge and plus q charge using the expression F is equals to Q naught times E. So the force experienced by this negative charge, since the electric field is going from left towards right, that is from positive towards the negative. So this side we have the positive and this side we have the negative. So this negative q charge will experience a force due to this positive side or positive field. So using the expression F is equals to Q naught times E, we can write force acting on this minus q charge at A as Fa. The charge that we have here is minus q. So minus q times the electric field in which this dipole is placed is E. So using the expression F is equals to Q naught times E, where Q naught is the test charge. Now here we have the charge as minus Q, so here we have written minus Q, and Fa is the force for the minus Q charge at E. So we have Fa is equals to minus QE. And since this is negative charge and this side we have positive, so negative will be attracted by the positive. So the direction of this force Fa will be along this direction. So Fa is equals to minus Q times E will be along this side. So this is the force experienced by minus Q charge. Similarly, this plus Q charge will also experience force towards right because of the negative field here, or negative side on the right hand side. So this positive Q charge at B will also experience force, which will be given by Fb is equals to, the charge here is plus Q, so we are writing plus Q here, electric field is E. So let this be our equation number 2. We are following the same equation, F is equals to Q naught E we have a plus Q charge, therefore instead of Q naught we have Q here. So this is the force experienced by plus Q charge at B. Now the direction of this plus Q, the force on plus Q charge will be this side. Since this side we have negative field and this is a positive charge, so it will be attracted in this direction. So this direction will have the force FB is equals to QE. So we can see that two forces are acting on the two charges. On minus Q charge we have a force minus Q times E towards our left, and on plus Q charge force QE towards right. So there are two forces. Now what is the net force acting on this dipole? So if you take the resultant, or if you add these two forces FA and FB, then you can see that this will be minus QE and this will be plus QE using equation 1 and 2. So since we have two equal forces with opposite sign, they will cancel each other, and the net force acting on the dipole, the net translational force acting on the dipole will be 0. So sometimes they ask you this question, what is the translational force acting on the dipole placed in uniform electric field? Then it will be always 0, because the two forces are acting in the opposite direction. So the net force will always come to be 0. But since these two forces are acting in opposite direction, they are equal and they have different line of action. Different line of action means they are acting on different lines. So this force is acting along this line and this force here is acting along this line. So these two forces, they have different line of action and they constitute a couple. Couple is a pair of force which are equal and opposite and has different line of action. And what this couple do? It rotates the dipole. That means a torque will be experienced by this dipole. So we will calculate the torque experienced by this dipole because of this couple. Now we know that the torque acting on the dipole, or torque, is given by, the definition is the magnitude of either force. So there are two forces acting, so you can take the magnitude of the either force and the perpendicular distance between the two forces. So this is the definition for the torque, which is magnitude of the either force or either force and perpendicular distance between them. So there are two forces, you can take the magnitude only. So when we take the magnitude, we don't have to consider minus or plus, it will be simply positive. So take the magnitude of either force, 1 or 2, and then we will need the perpendicular distance between them. So for that, what we will do here is, we will produce this backwards, the force FA, the line, we will produce this backward and we will simply drop a perpendicular from point B. So this is a small construction that we are doing here. Let this point be, let's say, O. So we have produced the line of force FA backwards and we have dropped a perpendicular from B which intersects it at O. So that you can see this line OB is perpendicular to both the forces FA and FB. So this distance OB is called as our perpendicular distance between the two forces. So let's put the values here and let's see. And since this is angle theta, this will also be angle theta because these are corresponding angles. So now let's put the value here. So you can take the magnitude of the either force. So when you take the magnitude, it will be positive. So we will have QE. And here perpendicular distance between them means perpendicular distance between the two forces is this line OB. So we will write OB here. So let this be our equation number 4. So now we need to find the value of OB here and put it in equation number 4. So let's find out the value of OB. So for that, we will take this triangle OAB. So if you take triangle OAB here, and if you take sine of theta means some people have. So perpendicular by hypotenuse is our sine. So we have sine theta equals to perpendicular by hypotenuse. Now in this triangle OAP, the side opposite to the angle is always the perpendicular. So the perpendicular here is OB, and the longest side of the triangle is always the hypotenuse. So hypotenuse is AB here. So we need the value of OB. So do cross multiplication here. So we will get OB is equals to AB sine of theta. Now from the diagram, you can simply see the value of AB. So AB is nothing but the dipole length, distance between the two charges here. And the dipole length is given by twice of A. So the value of AB is twice of A. So let this be equation number 5. So what we have done here, we have simply found out the value of the perpendicular distance OB. For that, we have used this triangle OAB and we have taken sine. Now you may wonder why only sine, why not cos? Because if we take cos of theta, then we will get curly brown hair. Now base here will be OA and hypotenuse will be AB. Now our intention is to find the value of OB. So if you use cos of theta, we will not get the value of OB here. So we will not take cos of theta. Similarly, if you take tan of theta, then we have turned permanently black. So here we will get perpendicular as OB and base as OA. Now here we will get the value of OB, but for that we need the value of OA. So in the diagram we don't have any value for OA. So we cannot take tan also. So the only trigonometric ratio that we can find out here to find out the value of OB is sine. Sine is some people have, so perpendicular by hypotenuse, you will get OB by AB. Our objective is to find the value of OB, so OB is here and we have AB here, and from the diagram the value of AB is already known. So for that we are taking sine of theta. So using that we get the value of OB as twice A sine of theta. Now we are ready to put this value in equation number 4. So you can put this value in equation number 4 and you will get the final equation. So let's put it here. So putting in equation 4, we have, so the symbol is called as tau, which represents torque. The magnitude of the either force is QE, and we are getting OB as twice A sine of theta. So let's rearrange this equation further. Tau is equals to Q into twice A E sine of theta. Now why we are writing Q and twice A together is simply because this product we call it as the dipole moment. So we can write it as PE sine of theta. So let this be equation number 6. So here we have used P, that is dipole moment, is the product of Q into twice A. So this is the expression for torque acting on the dipole when it is kept inside a uniform electric field. Now this same expression sometimes they ask in the objective question in the vector form. So we can write this expression, that is equation number 6, in vector form also. So let's do that here. So in vector form, so this is important, they ask you this in the objective question or 1 mark question. So in vector form, we can write this expression as tau vector is equals to P vector cross E vector. So in vector form, the torque experienced by the dipole when placed in uniform electric field is given by tau is equals to P cross E. Now how did we get P cross E here? In class 11 in vectors we have done this, that is cross product. So whenever you take the cross product of any two vectors, then it will give us the magnitude of the two vectors times sine of theta. So here in our relation what we have is we have PE sine of theta. So if AB sine theta is equals to A cross B, then PE sine theta we can write it as P cross E. So this is how we are writing tau is equals to PE sine theta in vector form as tau is equals to P cross E. So this is a very short derivation, but sometimes they'll ask you this derivation for 2 marks, or sometimes they will ask you just the objective question and this equation is also important for doing the numericals. So you have to remember this expression, that is tau is equals to Pe sine theta, and in vector form tau is equals to E cross E. So with this we have finished the topic, that is torque acting on a dipole in uniform electric field. If you are liking my videos, if you are learning from my videos, then please do like, share and subscribe my videos, and do comment. If you want handwritten notes, or if you need videos on any of the topic, then please do let me know in the comment section, and do like the videos and share and subscribe. Thank you.